All right, skill number 12, graph linear inequalities. Each one will be graphed on its own grid. For the first one, I like to think of this kind of like a three-step process. First, let's find the intercepts for the equation that's going to be that boundary line. And then we'll decide what kind of boundary line we draw. Is it going to be solid or dash? And then on which side of that boundary line are all the points that work or that are solutions of this inequality. So first thing is this. Let's rewrite the problem as 4x minus 6y equals negative 24. And just make an xy table and find the intercepts. Let's just find two easy points that are going to graph that boundary line. So in this problem, if I put in x equals 0, 4 times 0 is 0, so negative 6 times 4 would give me negative 24. There's one point. The other point, if y is 0, negative 6 times 0 is 0, all of this is 0, so 4 times 6, or negative 6, will give me negative 24, so that's this point. So those are my 2 points that I'm going to connect to draw that boundary line. So here's 0, 4 right here. Here's negative 6, 0 right here. Before I connect these 2 points together, I have to know is it solid or dashed. So equal to means the points on that line are solutions. This says greater than, but not equal to. So that means the points are not solutions. So when I draw this line, I am not going to do a solid line. It's just going to be a dashed line. So these are the places where the points that work as solutions and the points that don't work are separated by this boundary line. Kind of like a fence that says points work on one side and not on the other. Now the question is, where are all the points that are solutions to this? Are they up here above this boundary line or down here? A point that I like to pick that's a fairly easy checkpoint is this point, 0, 0. So I want to check 0, 0 and see if that point works as a solution to the original problem. If it is, all the points on that side of the boundary line where 0, 0 is will also work. So let's try 0, 0. If I put in 0 for x and 0 for y, I get 4 times 0 minus 6 times 0 is greater than negative 24. 4 times 0 is 0, minus 6 times 0 is 0. It says that 0 is greater than negative 24. Because that's true, that 0 is more than negative 24, that means that not only does this point work, but all the points down here work. So this is my solution. Everything down here. So I shade all the points down here. Any point you would pick in this shaded area would be a solution to that inequality. So there's many, many solutions to a linear inequality. So graphing is a good way to show all those solutions. Second one, same idea. Graph that boundary line first. So we have 5x plus 3y equals 15. So graph it using a quick x and y table and find intercepts. So 0 and 0. If x is 0, this is 0. 3 times 5 is 15. If y is 0, this whole term goes to 0, and 5 times 3 is 15. Those are my 2 points to graph, my x and y intercepts. Here's 0, 5. Here's a 3, 0. Before I connect them, make sure it's solid or dashed. This original problem was less than or equal to. The equal to part says, yep, the line is part of our solution, and points on one side of that line. So here's my boundary line. After I connect it with a solid line, I've got to decide where the points are that work. I'm going to try 0, 0. It's an easy point to check. And math with 0 is fairly straightforward. So I'm going to check this point, 0, 0, and see if it works. Is it really a solution to the original problem? 5 times 0 for x, and put in 0 for y, and see if this is a true statement. Is 5 times 0 plus 3 times 0 less than or equal to 15. 5 times 0 is 0, 3 times 0 is 0, all of that gives me 0. Is 0 less than or equal to 15? Yes. So because 0 is less than or equal to 15, this point works, and any point on this side of that boundary line works. So we shade in everything over here. Always pick a checkpoint and test it. That's a safe bet versus anything else you might do. All right, study those 2 examples. Your solution is the graph. That's the graph that you want to be able to show. And here are 2 problems for you to practice. Once again, find the boundary line and solve these by graphing. Pause the video, work them out, and then when you're done, watch the rest of the video and check your accuracy. All right, I'm assuming you finished these 2 problems. First, for these 2 problems, find that boundary line. So it's negative 2x plus 7y equals 14. Find it equal to. That's that line that separates points that work and points that are not solutions. And let's find that by just making a quick x and y table and putting 0 for x and 0 for y. 0 for x means y has to be 2, because 7 times y is 14. 0 for y means that x has to be a -7, because -2 times -7 is 14. These are my two intercepts, x-intercept and y-intercept. And now before I connect those with for my boundary line, I notice it's less than or equal to, so that means it's going to be a solid line, because it's equal to, and it's going to be the points on one side of this line. So not only are those points solutions, but also points on one side of that boundary line. So I check a point, easy point to check for me is a 0, 0. So check that point and see if that point works. So I'm going to check 0, 0 and see if that's a solution to the original problem. If I put in -2 times 0 and I add that to 7 times 0, is that a solution? Is that less than or equal to 14? This is 0 and 0, so I get 0 for -2 times 0 plus 7 times 0. And because 0 is less than or equal to 14, that's true. That means that 0, 0 is a solution, and any point on that side of the boundary line. So all of these points are solutions. So you shade in everything down here. Last one, first find that boundary line. So rewrite the inequality as an equation, so make it equal to -12. Find the x and y intercepts. So x is 0, y is 0. If x is 0, 3 times -4 is -12. If y is 0, -6 times 2 is -12. So those are my intercepts. So we have 0, -4, and then we have 2, 0. Then the question is, when I connect them solid or dashed, it's greater than, but there's no equal to part, so it's going to be a dashed line. So points on this line aren't solutions, but this line is simply going to separate the points that are solutions from the points that are not. So here's my boundary line. The question is, which points work? The ones over here or the ones up here? I'm going to check 0, 0. It's an easy point to check. Doesn't matter which point you pick, but I want to pick numbers that are easy to work with. If I didn't pick 0, 0, I'd pick positive numbers, like maybe the point 1, 4, or maybe a 5, 6, or something that I could check that would be positive numbers and not on that boundary line. 5, 6 would be tough. Maybe pick 4, 6 would be a better one. So try 0, 0. If I put in x is 0, so -6 times 0, plus 3 times 0, is that greater than -12? This is 0, this is 0, so I get 0 is greater than -12. That is true. So because 0, 0 works, everything on this side of the boundary line works. So your solution is not the boundary line, but all the points on the left side of that boundary line. Now the 4 examples we've seen for skill number 12, the 0, 0 worked every single time. Not always going to work. I just want to point that out because coincidence, you might see a pattern there. It's not a math pattern. Just happens to be that for the 4 problems that we did, it did work. So that is the end of skill number 12.